question until this point? If no question, you will see in the slide there is an example. So I will work on that example. Okay, on the impulse turbine. Okay, remember we are still dealing with this. Okay, this we will consider in the next class. Reaction and transition. Okay, now when we are dealing with the impulse turbine, we will still using the so-called extended Bernoulli equation. We will still using it. I have a big whiteboard there. Why are I still using this one? Okay, now the question is: you have a elevated lake. Okay. If you go to Ulu Kinta, there is a one big water catcher, what do you call it? Reservoir by LAP. The head difference, between the lake and the processing facility is 100 meters, right? And then the Q is roughly about they said 2 million. Very big, some million meter cube per day or something like that. My rough estimation, if we can generate electricity on that thing, you will get roughly about 30 megawatt, which is more than enough to drive the facility of that LAP, right? But then, when I ask them why they don't install the power plant, they say because they do not want to involve a mechanical system that may have, because when you are having a mechanical system, you have a grease, right? You put lubricant on it, of course, right? Lubricant will be there and some other thing will be there. They do not want to contaminate the water. That's why at the end of the day, they decide not to put any turbine on that. And then they will just use TNB to supply the electricity. Actually, if you can discuss with the Perak MB, you want to install this blah blah blah, you say that you will generate this, can be reached because the power generated is quite big. Okay, for that kind of head, you can either using a Pelton turbine or you are using a Kaplan turbine because the head is 100 meters. Very high. Huh? If you look at the 100-meter high, it's very big. And also the flow rate that is distributed by those LAP to all Perak is very big. So if you can utilize those energy, you will be rich. I mean, the overall Perak. Anyway, so this is what you will have. You have an elevated tank. Elevated reservoir. The Z here is 60 meter. Okay. The length of this pipe is 300 meter, which is expected. Okay. Do not think that when you have a dam, then your generator will be next to the dam. No. Usually you will have a penstock that drives the water from those reservoir down there very far. So in this case, you have 300 meters, and the diameter of the penstock is 20 cm, right? And then over here, we take the outlet of the jet as our base elevation. So here you have this one is equal to 0 meter. Okay. So this one is Z1, this one is Z2. Okay, sometime the problem given to you is that Z2 is not at 0 meter. This base, this reference elevation can be some meter, but that doesn't really matter. At the end of the day, you want to know the elevation difference, not the absolute elevation, right? So sometimes this one is not 0, it can be 10, it can be 12, it can be some value. because it depends on the elevation of that location to the sea level. Usually when you are talking about the elevation of that location, we are considering it based on the sea level, right? Like Sri Iskandar is 300 dpl, above the sea level. Okay, so this can be some number, not necessarily to be zero, right? But we just need to find the difference between two. Okay, and then the maximum or okay. In this case, actually beta is given. Beta is 150 degrees, right? This is the supplier data. The beta is 150 degrees. This is the optimum beta. Okay, and then the diameter 2r, right? The diameter of this, the diameter is 0.9 meter. Okay, and then the friction factor of this is 0.02. Okay, now